First of all, I would like to thank you, Perry, for the introduction, and I would like to thank you also for the invitation. It's a great honor for me, honestly. It's very good to be here. I will present some, hopefully, interesting data regarding preservation efficacy test, also known as PET, or Antimicrobial Effectiveness Test, or Challenge Test. It's the same test. And then, as you mentioned, I will try to answer your questions. Let's proceed with the presentation. Some key discussion points on this presentation. We will see together a small introduction regarding the sources of microbial contaminants, the fate of microorganisms when entering cosmetic products, before proceeding with some definitions regarding preservation and microbial protection. And then we will move into the core of this webinar regarding preservation efficacy test, principle, main protocols, the importance of this test method, microbial strains, validation of the method, criteria and interpretation of results, and of course, some limitation of this test. So, which are the main sources of microbial contaminants? The main sources are four. The first is the manufacturing environment. The second are the raw materials. The third is the packaging. And the fourth is the consumer. Starting with the manufacturing environment, microbes associated with dust particles from outside atmosphere may contaminate unprotected product. Similarly, aerosols created by turbulent flow or liquids may also give rise to significant numbers of airborne organisms. Thus, the operations of sinks, drains, running water, and vigorous cleaning of plant will generate microorganisms, and one must be careful when he performs such activities. In addition, inadequately cleaning of equipment between uses or any stagnant water that may be collected in points will create favorable conditions for biofilm formation, which eventually will contaminate the product. And of course, personnel is a main source of microbial contaminant through skin shedding. Regarding raw materials, contaminants, especially in raw materials, are very important because not only they may directly contaminate the product as carryover, but also because they may contaminate the manufacturing plant. So it will be hard to eradicate and often will result in intermittent or continuous contamination of the product. From the main raw material, of course, is the water, which has a widespread use in cosmetic industry, and of course is a primary requirement for microorganism growth. And other raw materials of considerations are plant origin and minerals, because they reflect the natural flora, namely gram-positive bacteria or spore-forming bacteria in case of plant origin raw materials, and some anaerobic strains which may be really dangerous for the consumers in case we're using minerals like talcum. Also packaging is very important because on the one hand, different packaging provide different level of protection, but on the other hand, if the packaging is inadequate, microorganisms might enter during product storage and use. And the last source of microbial contaminant is us. We are the final abused product that the product has to withstand. For example, if the product is multi-use, then microorganisms may enter after its use. And additionally, to make things more hard for the formulation, we store our products into our bathrooms, in which the environment is very hot and humid, and these are conditions that may favor microbial growth. So, we saw the sources of microbial contaminants. Let's discuss about the fate of contaminants when they're entering cosmetic products. They will either decline and eventually die, or immediately die in case we're having, for example, a certain production stage which includes an elevated filling temperature. For example, during production of a lip balm, which the temperature is above 65 degrees. Otherwise, death will eventually occur if the formula is unsuitable for growth due to its intrinsic characteristic, or if there are no appropriate nutrients available. In case we're having spore-forming bacteria or molds, On the other, we will have a static contamination, meaning that the population will be relatively steady throughout its product shelf life. This is happening because while spores are generally resistant to heat and chemical agents, they are incapable of rapidly multiplying unless any change on the conditions of the product will occur. And the third scenario is if the conditions are favorable and the level of contamination is relatively high, then the microbial population may actively start growing and multiplying, having as a result alternation in pH values, phase separations, alternation of physical characteristics, or discoloration that we really don't want.